Everything you were taught in school about how the universe works is officially outdated, as our fundamental understanding faces a massive shift. For decades, physics has rested on four unshakable pillars: gravity, electromagnetism, and the strong and weak nuclear forces that govern all matter. These forces dictate how galaxies hold together, how atoms form, and how the very fabric of our reality maintains its rigid structure. They are the absolute rules of the game, the constants that scientists have relied upon to map the cosmos for nearly a century. But in a stunning turn of events, researchers have just done the impossible, potentially shattering the foundations of modern scientific theory. They have successfully activated the world's first nuclear clock, a device of such extreme precision that it operates on a different scale entirely. By doing so, they may have just detected a ghost in the machine, a mysterious, elusive fifth fundamental force of nature. If this discovery holds true, we are not just adjusting physics textbooks. We are actively rewriting the laws of the universe itself. To understand why this is driving physicists to the edge of their seats, we must look at how we measure reality. For the last 70 years, our most precise tools have been atomic clocks, which track the predictable jumps of electrons. These devices are marvels of engineering, accurate enough to lose only a single second over the course of several billion years. However, electrons are notoriously noisy, easily disturbed by magnetic fields, stray radiation, and the chaotic environment of the atomic shell. To pierce through this background noise and find truly hidden forces, we needed to look much deeper into the atomic structure. We needed to look inside the nucleus, the tiny, dense core, where the true secrets of matter are tightly bound together. For decades, building a nuclear clock was considered technically impossible because the energy required to trigger it was simply too high. The barrier to entry was immense, requiring technology that existed only in the realm of theoretical physics and science fiction. Until now, that is, as a global team of physicists finally managed to tick the nucleus using thorium-229 crystals. By employing hyper-precise ultraviolet lasers, they have finally unlocked a way to measure time at the very heart of matter. Why does a hyper-precise clock matter to you, the average observer of the cosmos? Because it measures the fundamental constants of nature. Physics has always assumed the laws of the universe are static, unchanging pillars that remain constant regardless of time or location. But what if they are not? What if gravity or the strength of electromagnetism changes ever so slightly across vast distances? An atomic clock could never notice these microscopic drifts, as the noise of the electron shell masks the subtle signals. A nuclear clock, however, is immune to these surface-level disturbances, providing a clean window into the quantum realm. By observing the nucleus tick at an unprecedented level of precision, scientists can now look for anomalies that were previously invisible. If the clock shifts by even a fraction of a second, it proves something else is acting upon it. An invisible hand, a fifth force, could be exerting its influence on the nucleus, hidden in plain sight all along. This is where artificial intelligence enters the equation, as the sheer volume of quantum data generated is too massive for humans. Scientists are now unleashing advanced AI models to crawl through this data, looking for the exact signatures of this new force. If this fifth force is fully confirmed by our AI models, it solves the greatest mysteries in scientific history. It could finally explain dark matter, the missing 85% of the universe's mass that we have never actually detected. We see the effects of dark matter on galaxies, but we have never been able to touch it or measure it directly. This discovery could bridge the gap between Einstein's relativity and quantum mechanics, creating a long-sought unified theory of everything. We could be looking at the foundation for entirely new technologies that were once thought to be impossible to achieve. Imagine manipulating gravity, discovering entirely new states of matter, or even altering the fabric of space-time for interstellar travel. We are standing on the precipice of a completely new era of human understanding, where the universe finally reveals its secrets. The universe has been whispering its deepest truths, and we have finally built the clock sensitive enough to hear it. What do you think about this discovery? Is the fifth force the key to unlocking dark matter, or are we chasing ghosts? The implications are staggering, and the data is just beginning to flow from these hyper-precise nuclear experiments. Drop your theories in the comments below as we navigate this transition into a new understanding of the quantum realm. Hit that subscribe button to stay on the absolute cutting edge of the universe with Just Science AI, and see you next time. With the nuclear clock now operational, we finally possess the extreme sensitivity required to detect microscopic drifts in the fundamental constants of nature. If these constants shift even by a fraction, it suggests the presence of an invisible influence acting upon the very fabric of space-time. To process the massive influx of quantum data generated by this device, scientists are employing advanced AI models to isolate potential signals. These algorithms work tirelessly to identify unique signatures of this elusive fifth force that have remained buried in the noise for so long. Confirming its existence would be a monumental achievement, potentially solving the long-standing mystery of dark matter that permeates our vast, expanding universe. Furthermore, this discovery could finally bridge the gap between Einstein's theory of general relativity and the complex, probabilistic world of quantum mechanics. This breakthrough could pave the way for a unified theory of everything, offering humanity the potential to manipulate gravity in ways previously imagined. We might one day even find ways to alter space-time itself, opening doors to the possibility of efficient, long-distance interstellar travel between stars. As we stand on the precipice of this new era, the universe is finally revealing its deepest, most guarded secrets to our instruments. This invitation to explore the unknown forces us to reconsider our place in the cosmos and the true, underlying nature of our reality. Every measurement brings us closer to understanding the hidden architecture that binds the galaxies together and governs the behavior of all matter. The hunt for the fifth force is not just a scientific endeavor, it is the next great leap in our understanding of existence.